Okay, now what I want to do is overlay on the histogram here a Gaussian probability distribution function. And it turns out that the Gaussian distribution probability distribution function is just equation number 3 in the report, I think. So it's just this exponential of the negative of x minus m squared over 2 times s squared all divided by root 2 pi times s, where m is the mean and s is the standard deviation for the data. So here's the mean and standard deviation for our data. Now remember, we have yanked out, this is the data for groups A and B minus one obvious outlier. So there's 19 data points here. Okay, so what I'm going to do is duplicate this function here in Excel. So I'm going to come over here, and actually I want this is going to be a smooth curve here instead of a point here and a point there and a point there every 1 megapascals, right? I want to split this up so it's a little smoother here. So I'm going to move this over here. And over here I'm going to create a new value. Okay, so what I'm going to do is make this 50 here. Now what I need to do down here is I'm going to increment that by, I don't know, about 0.4, say, so this is 50.4. So if I take that and expand it down here, we'll eventually get to 60, like that. So going from 50 to 60. 50 is right here, 50.5 all the way to 59.5, 60 right there. Okay. And now I've got to actually duplicate the. So this will be give me more data points. So I'll get a smoother curve than if it was just those 10 data points right there. So now I've got to duplicate this formula right here in Excel. So again, that's that's that exponential function there. So I'm just going to go over here and say this is equal to exp of negative parentheses. My x value is right here. It's really the strength, the yield strength, but that's what's going to be plotted. That's what is plotted on this axis right here. And we're subtracting from that the mean, which is down here. I don't want that ever to move, so I'm going to give that some dollar signs there. That just locks it into this cell. As I copy this formula down, it'll stay locked on that cell right there. I'm closing my parentheses and squaring that, like that. I'm actually going to put an extra set of parentheses around here just to make sure that we don't get any weird order of operations things going here. So that's this whole thing right here is going to be divided by that 2s squared. So this is divided by 2 times, and this is the standard deviation right here. It's squared, and we're going to close off. Oops, I need parentheses here too. Parentheses there. So that gives me this part here. Now I have to take the exponential, so I'm closing off the exponential right here, and I'm dividing this by a square root of 2 pi. So this is square root of 2 times pi. Multiplying that by, again, by the standard deviation, like that. Looks like I have a spelling error there. So this should be the value of this smooth curve here at 50, right there. And I got to make sure to lock those other guys in there so they don't move too. So this I got to lock in with dollar signs, and this I got to lock in with dollar signs so that when I go down here to the next one, this one's bumped down correctly. it's no longer 50, it's the 50.4 there, but these guys are still locked in there. So it looks like I've done that correctly. So I'm just going to double click here and propagate that down. So notice it starts really small here, comes to some max over there, and then back small again. So it's going to go like that. Okay, I can actually do a plot of this now. Again, just do an insert like that, and there is that probability density function. Now all I got to do is sort of superimpose it on top of that. Okay, and all I have to do here is go copy, and then come back over here and say paste. Now, this switched back to a curve rather than my bar chart, and this is not very tall. And what you have to realize is this probability density function here, if you integrate from minus infinity to plus infinity, you end up getting 1. Whereas here, if I count up all the bars on my bar chart, I'll get the number of samples I actually have, which is 19. So adding up and getting 19 and integrating and getting 1 is sort of the same thing. So what I have to do is actually multiply the probability density function here by 19, and I should get smooth there. So I'm just come back here and say it's equal to 19 times that, because I had 19 samples. And again, double click to propagate that down. So now that's what my probability density function looks like. I need to change that back to a histogram. Let me get rid of this, delete. Okay, and again, I'm going to click on this and come back to my format, my chart design here, change chart type back to the column plot, right? And boom, something bad happens. And the reason is because this really is an XY data set. So if I say select data here, and this is actually my series 1 now, it has X and Y values, but the column chart only has Y values. These are not real X values. It just says this is the first one, then there's a gap, and the second gap, and there's another one. So this is like a 1 through 10 there. Whereas we're starting ours at 50 to 60 there. So what I need to do is move this down there. So 50 wants to be 1, and there. So what I'm going to do is I'm going to add in a column there. And here I want this to end up being 1 and that to end up being 10. So I'm just going to take this and say it's equal to that minus 50. So that slides this all the way down to 0. And actually, what I don't want it to be 0, I actually want the zeros over here. 1 is over there, so 1/2 is right in the middle there. So I actually want to, not subtract 50, but 49.5. That means that this data point right here is 0.5. And I propagate that down 10.5 there, which means I have an extra thing there. So I'm just going to get rid of this because I only want to go to 59.5 there. So I'm just going to delete that point right there. Select data and actually delete that data series. Get rid of that. So I just have the bar chart again. Now I'm going to come here, insert the plot, copy this, get rid of that chart, and paste it here. Okay. And then again, this needs to be the column chart, so I'm going to say change this back to a column. And there you go. There's the probability Let's change this back to, remember for histograms you typically want to have these things wide, so I'm going to format the data series, take that gap back down to 0, and hit OK. And there is my histogram with the Gaussian distribution on it. And that should look a lot like that middle one right there. And in fact, yep, it sort of nips this right here, clips that corner right there, comes a little high of those two guys right there, and then down there. So yeah, this is the same thing we got when we did this in Mathematica. Hope that helps.